are connected in a way that causes the correct policy, and you get a reward, you want to somehow reinforce that architecture. And there's lots of ways of doing this, essentially through back propagation and so on and so forth. So another area where a lot of research is going into deep learning for reinforcement learning is called Q-learning. I talked about this in the last video, where this Q or quality function essentially kind of combines the policy and the value, and it tells you jointly how good is a current state given a current action A. Okay, and so assuming that I do the best possible thing for all future states and actions. So right now, if I find myself in state S and action A, I can assign a quality based on the future value that I expect given that state and given the best possible policy I can cook up. And so again, there are deep Q networks where you learn this quality function. And once you learn this quality function, then when you find yourself in a state S, you just look up the best possible A that gives you the highest quality for that state. And this makes a lot of sense. This is a lot like how a person would learn how to play chess, is they would kind of simultaneously be building a policy of, okay, well, here's how I move in these situations, these are the trades I'm willing to make, and you're also building a value function of how you value different board positions and kind of how you gauge your strength and the strength of your position based on the state. So it kind of makes sense that this would be an area for really expanding with deep neural networks, because these functions might be very, very complex functions of S and A, and that's exactly what neural networks are good at, is giving you very, very complex, representing very complex functions if you have enough training data.
This is what we're doing.
That's what we're talking about here.
We are doing all of these things.
Challenges of regular reinforcement learning.
So we're looking at combining. We're looking at combining the state with some policy and then creating a queue. We actually need to modify our design.
At the very end of my chess game makes it very hard to tell which actions actually give rise to that reward. And so you're going to do some of the same things that you would normally do, like you might use reward shaping to give intermediate rewards based on some expert intuition or guidance. And there's lots of other strategies like hindsight replay and things like that, okay? But the basic idea is we're going to take the same reinforcement learning architecture, and we're going to either replace the policy or the Q function with a policy network or a Q network. Good. And
a hindsight replay mechanism might be really cool. But only at the end. Reward grid. Do random choice. We almost have interaction with the cell, kind of. Your table for state action determination, integrate state as a key. So let's redefine this. Consider hindsight mechanism. Implement deep reinforcement learning. So what we want to do here is we want to implement neural network for state determination, and then implement, this will be actually really good optimization. This will help speed up our learning and increase the quality and dimensionality all at the same time. This is like a huge upgrade actually. Implement Q table to determine best action from state plus S. Consider hindsight mechanism for end of life learning. And then we could cross entropy shared learning between child and parent. So I've got this idea of allowing a parent and a child to share some of their experiences as they learn. So the learning would be distributed to agents, and then those agents would cross-evaluate for better and worse. That's the idea. But anyway, let's go back to this video. See.
All of this kind of exploded on the scene because of this 2015 Nature paper, Human Level Control Through Deep Reinforcement Learning, where these authors from DeepMind essentially showed that they could build a reinforcement learner that could beat human level performance in lots of classic Atari video games. So I'm going to hit play. I love this one. This is one of the first ones that got me really excited about this. So this reinforcement learner is essentially trying to maximize this score by breaking all of these blocks. And after a few hours of training, it has an epiphany that only really excellent human players ever reach. So it essentially finds an exploit in the game where it realizes that if it tunnels in one side, so it's going to tunnel through here, if it tunnels through one side, it can essentially use the physics of the game to break all of these blocks for it. And that's pretty amazing. So it, in a short amount of time, learns a really advanced strategy that only a few humans, only a small percentage of humans would actually learn eventually. So really impressive. This is a beautiful paper, by the way. You should go read this. They talk about how they actually build their networks. So they use the pixels of the screen itself as the input, and they use convolutional layers and fully connected layers, eventually deciding what the joystick should do, what actions to take. And
I thought about using
like other
convolutional
examples in neural networks, this was the paper that really brought reinforcement learning and deep reinforcement learning back to to the forefront of everyone's mind, because this showed performance that hadn't been attainable before. So this is a lot like the ImageNet of reinforcement learning. Okay, this brought it back into the forefront. Since then, so Google bought this company for $500 million because this was, promised a big step towards general artificial intelligence, or an artificial intelligence system that could get good at lots of things rather than just one very specific task. And since then, billions of dollars have been invested into reinforcement learning in general and deep reinforcement learning by companies. And so in this original paper, these are all of the Atari games that they try out. And this is the level. Above this, they're at or above human level performance. And there's only a few games that they're below human level performance. And I actually think it's pretty interesting to look through these and figure out why this DeepMind was unable to figure out these games, but it was able to figure out these games. That's kind of an interesting exercise. Actually, I will point out that the algorithm in this paper, you could train it on one of these games and it would get really, really good. But that same learned algorithm, that reinforcement learner, cannot then be used to play another game without completely retraining it. And so it's still a ways away from where we want to be. We want to have a learning system that can learn to play all of these games. And if it learns one, it can learn how to play the other faster and better, just like a human does. We're still a ways away from that, but tons of people are working on it. It's one of the big problems in the field, is kind of transfer learning and general artificial intelligence using reinforcement learning. So building a learner that can learn lots of things and learn faster from its experience. That's what humans do. You get a kid, you teach them tic-tac-toe. Tic-tac-toe is easy. They learn the rules, they learn how to not lose. Then you give them checkers. Checkers is a little bit more sophisticated, but they remember everything they learned from tic-tac-toe, and they learn checkers faster. Again, they learn how to not lose. Then you give them chess. Chess is a truly open-ended game for most humans. It takes a lifetime to master. And so based on what they know from tic-tac-toe and checkers, a child will learn chess. They can transfer some of that over, and then they go into the real world and they learn lots of other skills, and those problem-solving skills transfer over. That's what we eventually want with computers. We're not there yet, but this was a big step, and it got everybody really excited, and it still does.
To get started in data analytics, you don't need previous experience or a degree. The Google Data Analytics Certificate will teach you to code in R, to code in SQL, data visualization, and learning how to problem solve like an analyst would. At the end of the day, being a data analyst is about communication.
Good. This is another video I love. This is from the Tech Insider showing, a lot of these reinforcement learning algorithms are used to train, so this is Google's DeepMind, to train the agent how to walk or run or leap or swim or fly in an artificial environment. And that's pretty amazing. I mean, this is a very complex, hard thing to do. We take it for granted. Our bodies are built to move very efficiently and agile and accurate ways. But this is actually very challenging to do. And so the fact that these algorithms in a virtual environment can learn how to run and walk and fly and swim is really promising for robotic technology. So we eventually want to learn how to do this in robotic systems and make our robotic agents more independent and more agile. And that's actually really hard. That step from the artificial world to the real world is challenging. So for example, to my knowledge, Boston Dynamics does not use a ton of reinforcement learning. They use a lot of physics-based modeling and kind of by-hand controls. Maybe they're getting into reinforcement learning, but there's a long way to go to do this in the real world. Still quite impressive. And this is a video I love. So this is training bipedal walkers, essentially generation after generation of reinforcement learner. And eventually the agent can learn kind of the physics and learn the right control policy, in this case to walk forward stably and keep its neck straight and keep its legs straight. And I think this is just a really cool video and a nice demonstration. I'll point out there's some great resources, other resources on YouTube you should check out for reinforcement learning. I learned about this in 2-minute papers, which is a great channel. I love learning about things in 2-minute papers. There's also Archive Insights has a great series on reinforcement learning, and Brian Douglas has a nice kind of reinforcement learning for control video. I believe it's on MathWorks. Okay, good. So really impressive performance just in the last 10 years because of these huge advances in the representational power of neural networks. These can represent functions that we previously couldn't represent because they're extremely expressive and we have lots more training data. We can train these because our computers have gotten so much faster and more powerful. And there's also open source software that makes it really, really easy to get started building these neural network representations. And so if you have any interest at all in modern reinforcement learning, you have to check out OpenAI Gym. This is a wonderful open source kind of development framework where you can try out your new reinforcement learning algorithm on all of these different systems, both Atari games, simulated running and pendula, and really cool physical systems that are hard to control, that are non-linear. You can get started really quickly and easily in the OpenAI Gym. And this is one of the big reasons things are taking off so fast, is because there are these amazing open resources for people to kind of try things out quickly and rapidly prototype. And again, you can try out all of these Atari games and see if you can build a reinforcement learner that can learn multiple Atari games with the same architecture. That would be pretty incredible. Okay, I also want to point out these things are getting pretty impressive. So almost everybody's heard of AlphaGo and how AlphaGo beat the human best Go player in the world, Lee Sedol from South Korea. The best Go player in the world was defeated by AlphaGo. This was a deep reinforcement learning algorithm developed at Google DeepMind with the sole purpose of learning how to play Go. Okay, and so I want to point out that so reinforcement learning is really good at learning the rules of the game and how to win the game when it's very constrained and when it has all the time in the world to try millions or billions of different Go games. So it's playing essentially with itself, getting better and better and better. Lee Sedol is a human, and he has a life. And although he spends much of his time in the Go world, he has a much, much richer, broader world. And he can go home, and he can go for a walk, and he can enjoy a sunset. And so I do want to point out that, and he can learn from AlphaGo and come back and be better the next time. And I think that's really also quite impressive, is that the human masters learned from DeepMind and actually got better once they played up to their competition. I think that's really cool. But anyway, this AlphaGo learning system, I think, is really interesting. This deserves a whole set of videos just to dive in. I think there's a documentary on this that's really interesting, so you should check it out. The original AlphaGo algorithm was based on a convolutional neural network, a CNN, and it had lots of reward shaping from humans. So expert humans guided the reward structure for this AlphaGo learner. So it didn't have to wait until the end of the game to figure out if it won or lost, because that would take forever. Instead, humans using reward shaping helped it to get intermediate rewards to help it to learn faster and give it a denser reward structure. Now that's tricky, because if a human guides the learning, that almost caps out how good it can possibly be, because it's fundamentally relying on human knowledge. So the next generation, AlphaGo Zero, which came a couple of years later, was even better and much more impressive. It didn't use any human features, no reward shaping. It only learned using self-play. It just played itself until it became so powerful that it could beat everyone in the world, including the original one. And it was based on a residual network architecture, kind of these that have these jump connections and are easier to train with backpropagation. Okay, so really cool advances, and that actually was one of the major advances that showed that ResNet was kind of definitely a major contender in the neural network architecture scene. Okay, so anyway, I think this is really cool. It's really interesting, but again, that is all that this algorithm does in the world, and it doesn't know how to take what it learned from Go and do anything else better. And that's that's what we need. That's what we want in these systems, is to get really good at a game and then take that and allow it, use that knowledge to get really good at something else. That's what we do, and that's really fun.
Do you want me to?
And, that's one of our strengths. So
do anything?
Some other examples. I love. This is a video.
Oh shit! I didn't realize I was still streaming.
from Stanford and from ETH Zurich, where they are essentially going to train using reinforcement learning flying uninhabited aerial vehicles, a helicopter and a quadrotor. So they can train these very aggressive, very high performance maneuvers using reinforcement learning. And so it is starting to happen that we're going from these simulated environments to the real world, to real robotic systems. But it's very challenging. It takes a lot of training and human guidance in general, and there's still limited examples of real robotic reinforcement learning. Actually, someone asked me in my class that I teach at the University of Washington, what are some real examples of reinforcement learning in industry? Because a lot of times you hear these game examples, Atari or AlphaGo, but I think actually one of the original ones was in elevator scheduling. So it turns out, and this is, I would have never thought, but it's really interesting. It turns out that in a really, really big building, like a super skyscraper that has tons of elevators and lots of floors, scheduling these things efficiently so that you don't get jammed up and so that people can get where they're going as fast as possible is a huge problem. It's a combinatorially hard problem. And it's really hard to solve. And reinforcement learning was one of the early algorithms that was used to kind of figure out this near optimal scheduling policy. Kind of interesting. Good. Okay, so robotic learning is getting pretty good. Okay, so I just want to take a couple of steps back and maybe summarize. So we've talked about reinforcement learning in general, both in the last lecture and in this one, as a kind of framework for learning how to interact with a complex environment based on your experiences. This is fundamentally biologically inspired. It's trying to mimic how we learn, how animals learn, how you train a dog, and things like that. And in the last 10 years, because of advances in deep neural network and major advances in this architecture and how we actually build and optimize these reinforcement learners, there have been big steps towards more powerful, more general learning frameworks that can learn how to interact with much more complex environments, like beating humans at AlphaGo or actually moving real robotic systems in really incredible ways. But there's still a long way to go. So again, I've said this a lot, I'm going to keep stressing this. We humans have bodies and we are curious. We go explore and we touch and we learn. And children are curious and they constantly are soaking up knowledge. And when they learn one thing, they can use it through this incredible human power of abstraction. They can use what they learn in one scenario in a totally different scenario. That is still a completely open problem in reinforcement learning. Maybe not completely open. It is a pressing and central challenge in modern reinforcement learning, is how to take what you learn and generalize, how to take a step back and use your expertise in one problem in one environment to solve another problem in another environment. That would be real general artificial intelligence. We're a long way away from that. So the good news is that that's not going to be solved in 5 years or 10 years. That's a hundreds of year problem. But it's really exciting because that means there's work to be done, important, interesting work in the field of reinforcement learning for lifetimes of research to be done in figuring out how to improve these systems, figuring out how to learn faster and better, both from what you're learning in the reward structure of this problem, but also from what you've learned in other problems. Okay, thank you so much for watching.
And we're back. The team is looking down the barrel of a 4:55 meeting.
They're gassed, Jill. Can they turn it around and make this meeting an email?
It's going to be a tough shot. But whoa there. They're getting an assist from Grammarly. Jones is taking the ball
Lame.
and running with it.
Hi, everyone. So today I'm really excited
Let's do it. Let's do it. Let's do it. Let's do it. You want to do it? Let's do it. Look at that. Look at the quality there. Starting to come together now. Look at that. Copy that image, paste it in here. It's only one thing that we want to add to this is a we want a cog. Look at that. We're going to scale it by a lot. Clamp it so it maintains aspect ratio. We don't actually know which way this thing's going, but I do know that we want to transform it. Just rotate it 180 degrees. There we go. And then we want to let's invert the colors. And then now we can do something like that. The normal. Yeah, I like the idea of having a gear in there. Let's scale it up even more though. Yeah, let's scale this guy up even more. Like that. Maybe we scale it even more. That's pretty cool right there. We can duplicate this layer and then we can scale it even more, but we'll decouple it and then we'll scale it this way just a little bit. Actually, we want to use a perspective. We want to pull it that way. Just squeeze it a little bit. There we go. And then we want to go back and invert the color again. So now we have this black layer in here too. Yeah. Duplicate layer now. We'll put this one on top. And we'll just blend them together. We'll say light and darken only. Let's just skim through. Hey, that kind of makes things pop. It's a little chaotic though. But I do like that. The hard light's cool too, actually. Oh, the only thing is that makes me feel like the fabrication needs to be moved up. But we could change the canvas size. We could make the height lower. We're cutting off some of it, but even smaller actually. There we go. That's actually pretty cool, I think. We've put a lot into this, but yeah, I think that this is probably it's a little hard to look at, but that's okay. It's supposed to be artistic and express this concept of fabrication and making things up and the duality of the problem-solving process, paradoxes even. I think we've done a pretty decent job of putting this together. This is, I guess, a work of art, essentially. Fabrication. What's messed up is we don't really have the back cover, and we're gonna need the back cover as well. Something I would be okay with doing though is let's save this one. And then let's save as fabrication full. And then what we'll do is we'll say canvas size, and then we'll turn the width into 7200 plus 300 for 100 for the spine, up to be 200. for the spine, at least. It's only 30 pages, but we do want to have a little binding. Canvas size. So let's do 7,400 like we talked about. And then we'll move this all the way to that side. That's what we want to do. Okay. And then we'll create a new layer. This new layer will have what we're gonna do. We're gonna keep this simple. Actually, we're going to alpha to selection, then go here, and then we select invert selection. We're going to paint it black. And then we're going to select shrink by 200. And that's how big our spine should be. And then is there a way to actually like type in selection editor? Sure, yeah. Okay. The way we're gonna do this, we are going to pick our paintbrush color. We're going to pick this gray color here. We're gonna just do the whole thing gray. Then we're gonna say new layer. This will be our red. We will pick this color here. Just gonna have this red to it. We will dodge. Hey, look at there. This one we will burn. Oh, we're not gonna burn that. We're gonna hard. Nope. Oh, we have to do. Okay, we can do a burn here. If we go and put a new layer here, and we paint it white for a background. Oops. But it's not a burn. There we go, linear burn. Then we want a new layer here, and then let's alpha to selection. Select shrink by 200. We're gonna go here. And we're gonna pick this like greenish color. And then that's when we're gonna go to the softest one, make it like really big, super low opacity. This is like a 7,000 pixel image, so we're operating at like a really high scale right now. It's pretty cool looking. I mean, back cover doesn't really have to be that great. So something we want to do is put our binding here. So we want to put fabrication. The Art of Engineering by R. Richard I. Christopher. We want this text to be white. We want to rotate it as well, but I want to make sure let's go to like 100. Let's just assume 100 is the right size. And then let's try to rotate it, because I'm pretty sure once we rotate it, it's automatically going to there's a oh yeah, I always forget about that. Text to path, no. Well, I know one thing. Oh, that's not what we want to do. We could do that though. This is one simple way to do it. Merge down and alpha to selection. And then we want to rotate this selection. We'll just make it 90 degrees. And then we want to move our selection to here. And then we alpha to selection again. No, we invert selection. If you see there's a ghost font here, we want to delete that. Actually, we just go to a new layer. And then we delete the other layer. There we go. And then there is our cover art. Wonder if we could figure out how to put this in Blender. I think that we actually have to create the whole mapping and then map the grid coordinates to a UV map. Like create the top and bottom parts, or create these separately. Like if we if we grew the canvas by 200 more for the pages. And then we grow the height 400 in both directions, or 200 in both directions. Would be 900 and then 5100. And then offset would be Y0. No, 200 that way. 0 this way. There we go. Fill with transparency. Select. Invert selection. New from visible. Export as full texture. No. Save as full texture. So we've got like 4 different versions of this thing going right now. But yeah, we want to delete. I want to get rid of all of these. Actually, we can just delete all of these. And then we want so one of these will be the top and one will be the bottom. So like if we took from right here, actually we gotta say right here, and we say we're going to paint it color of like paper-ish. We want to create some like lines, so we're gonna use like a scratchy texture. Doesn't have to be exact. We're also gonna like add in darker ones. Doesn't have to be right. We're gonna want to move this same texture over to the other side. And then that will create our top and bottom bindings where the book is. Then we want to create one right here as well. Oh, that's pretty good. That was actually really good. Want to make sure we're not cutting off our book though. GIMP is such a good program. But yeah, we will create our textures here now. We gonna do it. Tell you what. Oh, dang, I need that selection. Why is it not painting? Okay. I have to go back to this color. And then smaller size. That was the smaller size, I think, helped to make it. Get this orange. Kind of looks like it'd be pages. Pages on book. Close enough. Let's switch it the right way now. Then we can export this as our texture. I actually messed up here. This is supposed to be after the 200 mark, so I just have to kind of like guess. Something like that should be our binding. I think if we're off, it might discard it anyway, but I don't know. We're gonna try to do something. I just think it's cool when they hide pictures on that part of books and stuff. And merge that down. There we go. Ah, we're missing some black there. It'll be interesting. Yeah. Looks like it could be a book texture. Export as fabrication full texture. I wonder if we can do this in Blender. Appreciate people tuning in, giving me the follows and subscribes and hit me up. I haven't gotten literally anybody in a Discord server yet, but that's fine. Not too hip these days. So let's close this. We'll save it. Yeah, that is the full texture. And then let's see if we can pull up Blender. So where is Blender? There it is. Documents. So if we take this cube, if we pull open this little transform menu here, we should be able to see a scale. Let's scale up the X. If this book is 70, if it's 3600, if we say 360. 360. That's our length. Our height of this thing was, I forgot what it was. Damn. Need to pull up GIMP. Where'd that go? We can go back into recent. We can look up the full. And then if we go to canvas size. So if it's 47 in height, let's just say 47. So X, Y, if we say, this should be, scale is 360, the Y would be 470, and then the Z would be just 100. Then we've got this big giant object that we can't even properly see. Our book wouldn't be that thick. It'd be 10. There we go. A little 30-page book. Now, for this to work, we're gonna just have to take it down in order of magnitude. We'll just have a super high resolution image on it, but that's good, I think. This would be our book. Now, the question is, can we go to our object, use a there's a trick to do this. It is a vertex weight. No, that's how you, okay, that's a different trick. UV project. Grab a UV map. Add our texture. I'm not doing this right, I'm sure. Image or movie, image, open, document, fabrication, full texture. Single image. Go to material preview. View as render. I think we need to go to the texture mapping. There should be in the material setting. Where is it? We need to go to material view. This is the only way I've ever been able to get this to work. Shader editor. And add a texture mapping. UV map. Fuck, how do I do this? I always forget how to do this. And then when I look it up, I feel stupid. How to map texture to object Blender. UV coordinates, right? UV texture coordinate. There we go. UV to normal. To color. Almost there. Texture. Mapping. Shit. Where'd our cube go? How we getting oh, because we don't have anything mapped. Color. I know that's not it. It's UV to normal. right? Not that either. It's scale to normal. I don't remember. Look at that. Yep, because it wraps the block. There we go. Now I don't know where to plug this thing in. That's where I always forget. I feel like it's like here. The material. Man,
Building your online business?
I always pull it up and then I feel so
Go to
stupid.
Wix.com and set up your store on a single integrated platform. Add products,
It's something like
showcase
that.
them dynamically, and seamlessly track your inventory.
It's not the UV
Accept
project.
multiple secure payments, and design your storefront.
Hello, JM here with a new tutorial on how to...
Bro, I've had my mic off this whole freaking time and nobody told me nothing, bro. I feel so stupid. I've been sitting here talking about this whole model I've been making.
What I'm going to create now a simple mesh using Blender 3 and then map the texture onto it using Smart UV Project for the wall around the window.
Yeah, that's all I care is the UV
Which will be
projection.
for the UV editor. The UV project add an image textured into the project.
Image texture, duh. Duh. There's so many options on here. That's what makes Blender hard. Color, base color. We're almost there.
Okay, in the viewport we can see, but of course the UV mapping has to be done. We have to match the UV islands to the correct. We open up again the A key, select in around the window editor
How
to the
do you
correct
do this one?
positions of the image. So we open up again a new window, which will be for the UV editor. Okay, but
Where's that at? Because I'm looking at an old version. It's not texture paint. There it is, UV editor. So where?
and I select the mesh in edit mode by pressing the A key.
Fabrication, full texture.
You see the UV islands on the right side in the UV editor. When I select the UV sync button, then the UVs that I select in the 3D viewport gets
I don't have no UV sync function. I don't know how to resize this to where it needs to be either, because it wants. I knew it was gonna want them on the side. I knew it. I knew it. Damn it.
selected in the UV editor as well. Now we can select the different parts, for example the faces for the wall around the window. But you see, we have to scale and rotate the UV islands, but I want the proportions to be the same for all the islands. So I select all and press S to scale them up all together.
So it's not letting me, I don't have the same thing I'm looking at. If we go to texture, I don't know. I'm not following along. We go to edit mode. Okay, I see now. We can edit these. The problem is this whole part needs to, like, we need to rotate all of these 90 degrees and then rotate them 180 degrees, and then this and this need to be so it kind of makes sense. There's some things you cannot do in this version, I guess you could say. That's not the right way to say it though. How can I put this? You can't add a vertex or delete one. So we actually need to go into like, you can do certain things, you can stitch things, you can merge things. Okay, we can split. So Alt M. Alt M. Nope. I know that we want this to go here. And for this to go here. We'll worry about these in a minute. I do know this part need to merge at cursor right there. This guy needs to go over here. This needs to be split. So we're gonna just move both of these down. This one will end up being right here. This point, we'll see how good my lines were. This one will be here. Cool. We are going to turn this thing into a book. Or try to. Yeah, so this is cool too. This guy goes here and this one goes here. That's why we need to split this sucker. This one goes here and this one goes here. Now, we need to figure out how to move that around. If we go to faces, is that how we split it? If we say split selection, yeah, that's how we do it. Then we go here and we just move this guy and go back to points and we move. Oh, it's fucked up. So we have to do the split and then move it. And then we have to split this one out too. Okay. So we got to do all of these faces separately. Then we can go back and we can merge those. Okay. I see. Merge at center. Then we can drag this sucker down and over. Look at there. Now we got our binding. And I mean, we were guessing it's not bad. Just gonna make sure we're on the inside of these. Yeah. This stuff takes time, but I mean, you gotta do it, I guess, if you want. You want to sell something that doesn't exist yet. Like, that's the whole concept, isn't it? As much as I hate to say that, you gotta put a binding on it, right? I think that's good enough. We'll just merge these at the center. Put these where they go. Kind of want to split these because I think I want to try to round it out and see if I can wrap the textures. Like if it'll subdivide these, I guess. I want to try to do something like that. We'll see what happens. It don't have to be perfect. But I do want to save this. We're gonna save my fabrication model. We'll save a Blender file. Then what do we do next?
Now a scale and rotate around the axis face. Now the only part this one here to in the viewport and try to match. Okay, now we have a pretty good matching.
So what am I missing? I'm missing one of these steps for
a shader editor and add an image texture.
when we go back now.
We connect it to the base color of the principal shader, and the image we can select here because it is already imported into the project. Okay, in the viewport we can see the image assigned to the mesh.
Okay, that's almost. Hey, you can see our book texture, but it did it to the wrong surfaces. Damn.
So we open up again.
Our name also is in the wrong direction too, it looks like. We did the wrong surfaces. Okay. How do we
select the mesh in edit mode to unrun the just mode? Okay.
how to rotate UV mapping in shader Blender.
Wix gives you the power.
I think it's just
website you need with full business functionality.
no
Design tailored just for you.
texture mapping,
Your website.
image texture.
Watch your vision come to life.
I already looked that up.
in minutes.
Mapping.
Control everything from the biggest tasks to the finest details. Personalized, optimized, ready to go live.
And press ESET to choose material preview to show the texture. And then I press A to select all the faces. I zoom out in.
Let's see, this guy's got him on here. Blendarian. Just look what he did. He put the mapping in there at the front. That makes sense. Color goes in here. Get rid of that guy. Then, where is it at though now? There's our book. I don't feel like this is doing it right. I feel like this is not the right thing. But maybe if we rotate it around the X, that'd flip it 180. What if we did it 90 degrees? No? 0. 180. Nope. We could scale the X and -1. Nope, none of that's working. Linear. Flat, repeat, image sequence. I think all of this is already done, defined here. Oh, we gotta go back to this UV editor, I guess. Texture node editor. Yeah, I think we do. Window, if we do a new window, we just make this one our 3D viewport. Material preview. So, if we assume how about this? How about we change the dimensions of the cube? That is the way. Go back to our 3D viewport. And we say this side is right. So the X dimension let's make this one 47. No. This is the one that should be 1. There we go. Look at that. So the Z should be 47. Looky there. And this one should be 36. And there's our book. That's fucking cool. That's so dope. That's so dope. Awesome. Where's our light at? I don't want to be in edit mode, I want to be in object mode. There we go. To change our light, we have to go into data, $6,000 because we're dealing with like giant objects. Gonna add a second light. This one's going to be sun. We don't want it to be 6,000 watts. We only want a 1,000 watt sun. And we want it to be way off over here. Okay, and then we also want our sun to be a little bit yellowish or orangish. We're gonna make our sun only have a strength of like 400. Even then, that's like ridiculously high. Strength of 40. Yeah, it needs to be a little bit more white. Let's just say 20. That's a reasonable lighting. Then we want to make one more of these. Have him be up here. Let's make the camera circle around all of this. This one needs to rotate this way. Actually, let's bring it over here. Point it this way. Like over here even. And we'll make this one like a little bit greenish color. And the spotlight. And we'll make it 1,000 watts. 10,000 watts. The thing about the spotlight that's cool is that it's got this scale. Not that it really does a whole ton when you put it in like arbitrary angles like this. But it almost acts like a flashlight. There we go. And where is this camera at? I almost want to put it on a table. Engine. Got music going, I didn't even know it. $3D is so cool. This is some rockin' ballads. I do know that much. Okay, look at that. Look at that. We are actually looking at the book. The camera is not depth of field. It's because we're so large. I actually do want to use cycles. We're all kinds of backwards now. Upside down and everything. We need the center on this whole position. There we go. We need to rotate this up. We need to rotate it this way. Move it over. Move it backwards. And then figure out how to change depth of view for camera render blender. Navigate to camera panel properties. Enable depth of field. We'll go back to Eevee. We'll try this, because Eevee's like the standard now. Depth of field, right? Max size. Adjusting the depth of field setting begins with setting the focus. I don't have that same setting here. That doesn't make sense to me. Yeah, we are in viewport shading. I know what it wants me to do. It wants me to scale all this down. Oh, it's upside down too. Move it here, move it here. Now if we go here to these 2 points, we should be able to see it, yep. We're still upside down though. Simple way to fix that though is to rotate it around the Y 180 degrees, bring it up. And then instead of trying to move the camera to the object, which is always really hard, you just move the object to the camera. Now the question is, why is it rotate around, scale it around the X, -1. Boom. Now we have to figure out, because this is not really the angle we wanted. Rotate it around the X 90. Rotate it around the X 270. Rotate it around the Z 33. We're just gonna like turn it where we think it's good. What are we looking at? There we go. It's weird how it like moved us to that. camera's looking at it inside out. That's the crazy part. All of our lighting's mixed up now too because we're on the wrong axis. So if we rotate around the Z minus, we scale around the Z -1 and rotate around the Z 180, there we go, then we'll be back on point. Rotated, we were actually already closer than we realized. I don't know where the sun is, I don't really care either. There we go. Let's take this light and just let's bring the light back a little bit. Like, you know, a couple thousand watts. Let's actually look in our camera and see what we got. I want to rotate it. Come on. 270. Nope. Rotate around the Y. Render image. Look at that. The lighting's a little bit hard, so we need to take this light . That's pretty good. We probably could have added some effects on here. Something could modify the texture. And then let's scale this one back up now. And let's actually move it away. It's not a bad light, it's just like a little harsh. We really haven't gotten another good light. We don't want to be wrapped around that light. We want to find our book. pretty cool. I like it. It won't let me, like, I could probably render this at a higher resolution, but it'll be alright. Then we can put this back in our software. Yeah, we can try to do something with this now. I do want to, like, try a little bit brighter here. Have this one be a little bit brighter. Maybe even rotate it this way a little bit. Maybe 21. 19, 16. There we go. Maybe. I don't know. I can't get it exactly right. Maybe we turn it this way more. Just can't get it exactly right. It's almost hard to read. It's supposed to jump off the page. It really is. I mean, that's like the whole point of this thing. We could make it a softer light at a higher intensity. Then we can do the same thing with this green light. There we go. That's actually pretty cool. It only needed just a little bit of that light. And then we can render the image again. That looks pretty cool. I like it. I like it a lot. Let me save this image. Save. Fabrication. Mockup. Cool. Cool, now we can like import that into other programs and we can do something with that as well. I'm gonna get off of here. I appreciate everybody that's taking the time to tune in and to check out my work, and I hope to share more in the future. Oh, now that I see it, that's the money shot. I can't not do that. We could add some effects here. We could add effects in other software too, though. Render image. Yeah. Oh yeah. Hey, Ruben. Thanks for tuning in. It looks like you already left though. Yeah, anyway, we will save as mockup 2. And then we'll save this model again.